on a bunch of different things. The first one was that I implemented a binary data structure that allowed us to transmit the information about the image along with bitstream. This contains information about the dimensions of the image and the quality of the compression, as long as anything else that we need to reconstruct it. The second thing was that me and Eric modified the AX25 header to cut down on the overhead.
So on the image compression side of things, we implemented most of the standard JPEG compression algorithm. JPEG compression begins by dividing up your image into 8x8 blocks, 8 pixels by 8 pixels in all 3 channels. Then for each of those blocks, you convert it from the RGB color space to the YCbCr color space, which is a luminance channel and 2 chrominance channels. The reason we do this is because humans are less perceptive to changes in chrominance, so we can compress those 2 channels far more.
So for the packets, we removed all the headers from the AX25 so that the only information that was contained were the info and the flags. So that saved a lot of space. For our experiments, we found that we could send over about 60 kilobits. So we had to make sure our compressions were that size. Beyond that, we also modified the given classes for the modem so that we could utilize the way we made our packets such that there was no headers. So we had to make sure the decode function would match that, match the change of indices. As for transmission and receiving, we had made a thread, we played it, and then it would end. And on the receiving side, we just listened indefinitely until we got the signal from the transmitter person, and then we end the